Does anybody remember anything about the two new ways of finding the area that we have? Anybody remember what they are? Either one of them? Nick?
If it was all sides, it was the square root of the perimeter divided by 2. And then
We call that the sine perimeter. Yep.
And then it was that minus each side length.
Exactly. Did you remember that on the quiz?
Yeah.
Okay. That is called Euler's formula, and that is a way that we can find the area of the triangle if we know all three sides. S, remember, stands for half the perimeter, the semi-perimeter. So if you happen to know all three sides, you are good to go with that formula. Anybody remember the other one we talked about? John?
I really know how to say this, like 1/2 of the side times the side.
You're saying it perfect. Side times side.
Then the sine of the angle of the
Yep. Sine of, I'll say included angle. That's the mathematical way of saying it, but it's the angle in between. Yep, that's exactly right. So 1/2 side sine. So now we have, well, we have a whole bunch of area problems on this paper, but the first one is this pentagon, inscribed in a circle with a radius of 5. Now we did one like this the other day, remember? What was our strategy? We thought of this as a bunch of triangles, and then we focused all of our attention on one of the triangles and said, okay, we're going to find the area of that triangle. Now, at this point, you have these two sides. Is there a way of finding easily and quickly either the other side, so we could do that, or the angle in between the sides, so we could do it this way?
360 divided by 5.
Oh, we can find this angle quite easily because all of these are congruent. They all add up to 360, and there's 5 of them, so that must be 72. So the area of that triangle is 1/2 5 times 5 times sine 72. Everybody good? That is not the answer though. Remember, that is just the area of this. So to get the pentagon, you're going to take this answer and multiply it by 5. All right, anybody have that answer? So we can make sure we're taking it in right. Total final answer?
Yeah.
59.44. Yep, I agree. Anybody have a question about that?
Those two formulas, do they only pertain to triangles?
Yeah, those are formulas for areas of triangles. Yes, indeed. All right, now we've got an isosceles trapezoid. Everybody remember what that is? I drew it for you. And our job is to find its area. Isn't that our job? Yep. Any ideas?
You make 2 right triangles.
Oh, well, we could. Is this what you're talking about, Robert? Drawing a perpendicular here and here?
Yeah.
Now let's talk about what we know having done that. How long is this right here?
10.
That's 10. So how long is this?
1.
So now I have a right triangle. This is a right triangle, like Robert said. And I know these two sides. Can I find the length of that dash thing I just drew down there?
Yeah.
How?
square of the
Pythagorean theorem, that's right. So it's gonna be the square root of 24, let's see, 2 root 6, if I rationalize it like a good math student.
Why wouldn't we use it as a decimal?
Why would we, if we cannot?
Are we trying to find the area?
We are, we're getting ready to do that. So we can find the exact area of this one. Now, if you happen to remember the area of your trapezoid formula, anybody happen to remember that?
Base 1.
Oh, someone make your geometry teacher proud. Well,
Base 1 plus
the
base
formula
2.
is 1/2 the height times b1 plus b2. Does that look familiar to you? So for our problem, if we're going to use that formula for our problem, what's our height? Yep, we just found that, 2 root 6. And base 1 plus base 2 would be 22. 10 plus 12. These are called the bases. These are called the legs. So it looks like 22 root 6 is the exact area of that trapezoid. Now, what are you going to do if you forgot your formula? Now, you still can do this. You're still going to have all this figured out. But what are you going to do if you forgot your formula? How are you going to find the area of that trapezoid? Huh?
Break it up.
Yeah, and it's already broken up, right? So you've got this rectangle in the middle. So we could find the area of the rectangle, and how do we find the area of the rectangle? So that would be 10 times 2 root 6. 10 times 2 root 6, or 20 root 6. And then you would have to find the area of the triangle, which is 1/2 base times height. Since we have the base and the height, we'll just go back to our old formula, which is root 6. But there's 2 of them. So you have the other triangle is also root 6. So you've got 20 root 6, a root 6, and a root 6, giving you a grand total of 22 root 6. So even if you forgot your formula, you can get your area by, like Trevor said, breaking it up into its little pieces. Is that okay? Now the next one is a bit of a challenge. I don't think we've looked at anything like this before. So let's see what kind of plan you have for this one. Your job is to find, this is somebody's lot, like your house is sitting on this, and your job is to find the area of it. Let's say you're the tax assessor, and you need to know what the area of this lot is so that you can assess the real estate taxes. All right, who's got an idea? No idea at all? Kayla?
Can you make the top part a triangle?
Can we make the top part a triangle? Well, we definitely want to make something a triangle. So let's talk about how we could split this up in maybe the most easiest way for us to handle. Dan? Dan is suggesting this, oops, and I absolutely love that suggestion, Dan. because not only does it create triangles, which, as Emma pointed out, if I'm going to use my formulas, I gotta have triangles, but it creates a right triangle, which are the special easy ones, right? Could we have drawn in this diagonal and made these two triangles? Yes, maybe a little more work that way. Let's see what happens with this situation. Now I'll call triangle 1 and triangle 2. Now remember how in this problem when we didn't remember the formula, we split it up and found the area of each piece and then added it all up? Let's try that here. Did we find the area of this triangle? Yeah, this is a simple one. For triangle 1, the area will be 1/2 the base times the height, which is, I should know that number, but I don't. 216? Triangle 1 is done. I know its area. So now all my energy is going to go to figuring out what the area of this triangle is. Now, is that a right triangle? No. So I'm not going to have this 1/2 base times height stuff happening. I'm probably going to try to find a side and an angle and do 1/2 side, side, sine. Or find all 3 sides and do Hero's formula. So looking at triangle 2, is there anything else we know or could figure out about it? Jamie? The red thing I drew in, we could find its length, couldn't we? 18 squared plus 24 squared. I'm sure that's something. 30? Is everybody okay with that? Wouldn't life be magnificent if we knew this angle? Because then the area would be 1/2 28 times 30 times the sine of that. Now before someone says it, let's think for a minute. Is there any reason that I would have to assume that that red line I drew in cut that angle in half? No. No. You cannot make that assumption. So how in the world am I going to figure out what that angle is? Grace? Oh no, go ahead. I bet you have a good thought.
Could you do sine of 24 over 30 to figure out what it was?
Okay, you are on the right track. Let's stick in our right triangle for a minute. And let me call this angle right here X. Grace is saying, we could do the law of sines, but since it's a right triangle, Grace is saying the sine of X equals 24 over 30. Now, is she correct? In this triangle right here, does the sine of angle X equal 24 over 30?
Yes.
So could I find angle X? And how would that help me? 105 minus it would be the angle I need. I don't need this one. I already know the area of that triangle. But I can find that one, subtract from 105, and get what I need. Okay. Now, how do I find angle X? What do I type into my calculator? 24 divided by 30, right? And then what? Yeah, inverse sine, arc sine, sine -1. So this angle is 53.13, I think. That is not the one you want though, is it? So we'll subtract from 105. And this one is 51.87. You okay? So what is the area of triangle 2? We're ready, we can do it now. What is the area?
30.
1/2, 28 times 30, sine 51.87. Beautiful. I got 330.38. But remember, what do you have to do with that 330.38? Add it to the 216. So 546.38 is square, I don't know, I forgot, was it feet? Square feet, yeah, would be your final answer. Okay. Who would be willing to walk us through that one more time, kind of recap the steps we went through? Anybody feel comfortable doing that? Robert?
So you find the area of the first triangle, which is pretty easy because you have both numbers. So you just do 1/2 base times height, and that's 1/2 times 24 times 18, which equals 216. So that's the first triangle. And then to figure out the angle of the second triangle to make it easier to find the area, you have to find sine over 24. Sine equals 24 over 30, and that's x. And then you subtract 105 minus 53.13, which gets 51.87. And then you plug that into the formula, 1/2 times 28 times 30, and then times sine 51.87, and you get 330.38, and then you add that to 216, and you get your answer.
Perfect. Now, a couple of comments. As always, there's more than one way to do the problem. Back here, we found this angle by doing sine x equals 24 over 30. Could we have done tan x equals 24 over 18? Yes. Or cosine x equals 18 over 30. You can use any of your functions to help you find that angle, not just the sine. You okay? No, some of you look a little dazed. Let's look at number 4. We have a squirrel in a tree spotting an acorn. So here's the ground, here's the tree, here's the squirrel, here's the acorn. Does that picture make sense to you? All right, where do I put the 280? Read the question carefully. What does it say? What's the 280?
Tree to acorns.
It's the hypotenuse. The acorn is 280 meters from the squirrel. There's the squirrel, there's the acorn, that's 280. Angle of depression is 23. Where do I put the 23?
No, it's 60.
Do I put it here?
No.
No. Angles of elevation and depression are always measured against the horizontal. So if you want to put it up here, you can, but it goes here, against the horizontal. I am the squirrel, looking straight ahead, and then I look down at my acorn. That is the angle of depression. Personally, I prefer to keep my angles inside the triangle. So if the angle of depression of the squirrel to the acorn is 23, what's the angle of elevation from the acorn to the squirrel? 23, because those are alternate interior angles.
Are you allowed to minus that from 9?
Oh, totally you are. Absolutely. This thing, 67, right? Absolutely you can. They add up to 90. Yep. Now, what do I want to know? The height of the tree. Oh, you have tons of options. What's your individual thought? You have a thought? Finding the height of the tree.
23 equals x over 2.
Somebody said sine 23 equals x over 280. Now, that's SOHCAHTOA. Can we be using SOHCAHTOA? Yes, because we have a right triangle. It's perfectly okay. Could you use your law of sines or something if you wanted to? Absolutely. But this is probably the easiest thing to do. So the height of the tree is 109.4. Oh, meters? Everybody okay? All right, one more. We have a man 6 feet tall. Okay, you need to be able to draw your own pictures here, folks. We have a man 6 feet tall. Okay, so here's the ground. Here's the man, 6 feet tall. And he's looking at a tower, 38 feet tall. So far, so good? Man looking at tower. If the man is 70 feet from the tower, what is his angle of elevation to the top of the tower? So here's the man looking at the top of the tower, and our job is to find his angle of elevation. Where is that? Where's my X go? Be careful. Is this X? No, not all of that. Part of that's X, but that's not X. Because angles of elevation are always measured against the horizontal. That's X. Here I am, I'm the 6 foot man, looking up at the top of the 38 foot tower. That is my angle of elevation right here. Any ideas how we can find that angle? Emma?
Oh, never mind.
Okay, Trevor?
Alright, so at the 6 and X, where that means you just draw that line across and you just find the rectangle and the right triangle.
Kind of like what I have already?
Yeah.
Okay, yeah. Now what?
You take 6 times 70 to get the angle of the rectangle, and then 1/2 70 times 38 to get the triangle.
Okay, wait, now we're not finding the area. We're not finding the area of this. We want to know what is that angle.
Sine X equals 32 over 70.
Oh, that dashed line we drew across is still 70. And Trevor said now this piece is 32. Does that make sense to everybody? Because you got the 6 foot cut off over here. So he said I got a right triangle here. And the sine,
I said tan.
I don't think I want to use sine.
I said tan.
Did you say tan?
Yeah.
Okay. The tangent of x equals 32 over 70. And how do I get x then? What do I have to do? 32 divided by 70. And then inverse tangent that. I got 24.57. Any confirmation?
That's what I get.
Everybody good? All right. I'm gonna change things up a little bit. We are doing so very well. But I think tonight, if you turn your page, the next page in your little packet is Prequest. And don't get scared. See the squiggly line running down through the middle? That's separating the problems from the answers. And then the answers are also continued onto the back. So there are really only 7 problems, although some of them have multiple parts. So that's your homework tonight. I want you to do Prequest 5.6 to 5.5 to 5.6. I'll have to change the assignment in Schoology, so you're hearing me telling you what the assignment is. It's Prequest, okay? That's what I want you to do tonight for homework.
This is fortunate the answer on the bonus was.
You know,